In this lab, we explored cardiovascular response to exercise by measuring how blood pressure and heart rate change with posture and exercise. We based this on the YMCA protocol, and we used a sphygmomanometer, a stethoscope, a polar heart rate monitor to collect our results. We started by having the subject laying in supine rest position for 3 minutes, and we collected the blood pressure during the final minute of that stage. For the next stage, the subject sat on a bicycle at rest for 3 minutes, and the blood pressure was taken again during the final minute of that stage. We continued with each stage of the YMCA protocol, making sure to collect the blood pressure during the final minutes. The YMCA protocol is a standardized outline that decides the resistance at each stage based on the subject's heart rate. We were monitoring heart rate throughout the test, and resistance for each stage was fitted to the subject's heart rate during that test.
Upon completion of our experiment, we were able to create 2 graphs from our data. Our first graph is our average heart rate versus the stages. We were able to measure heart rate using beats per minute. Looking at the graph, during supine going into standing, there is a slight increase due to a slight increase in heart rate, and there is a large jump from standing to stage 1 due to the exercise starting during the YMCA protocol. And going through stages 1, 2, and 3, you can see how the heart rate is starting to lower due to the continuance of the exercise and how the heart rate is starting to balance out. Our second graph is the average systolic and diastolic blood pressure that we measured during each stage, and we measured this in millimeters of mercury. And our systolic blood pressure is measured during ventricular systole when blood is ejected from the heart. This is represented by the blue line. And diastolic blood pressure is measured during ventricular relaxation, which is represented by the red line. And we also calculated mean arterial blood pressure, which is represented by the black line. And with all of these lines in this graph, you can tell that during stage 1, blood pressure increased due to the increase in heart rate and exercise.
During exercise, MAP showed a slight increase, but generally remained relatively stable. This is because the body balances between different changes, which is the resistance due to the vasodilation in the active muscles and cardiac output, which is increasing significantly due to the higher heart rate and stroke volume. What drives this is the sympathetic nervous system that's activated during exercise and calls the vasoconstriction that maintains blood pressure. Which works in the muscles due to the change in exercise. We calculate this through MAP, which is the cardiac output, and the TPR, which is when the TPR decreases, there's a larger rise in cardiac output. We measured this by using the MAP, which is systolic minus diastolic multiplied by 1/3 plus the diastolic blood pressure. And then this showed that the systolic blood pressure increased more than diastolic blood pressure during exercise, leading to an increase in our MAP.
So for heart rate change during exercise, there's a direct relationship between the two. As you exercise more, your heart rate also increases. This is mainly due to the sympathetic nervous system activating, which helps nutrients and oxygen travel more quickly and efficiently throughout the bloodstream. Stroke volume also increases due to the stronger ventricular contractions and increased venous return, which then leads to greater end diastolic volume. However, with very intense exercise, the stroke volume could eventually plateau. As Cindy said, mean arterial pressure rises moderately, cardiac output rises significantly, but the total peripheral resistance falls a little due to vasodilation, which leads to a slight overall increase in the mean arterial pressure.